So hello my dear students and learners. In the series of data structures and algorithm, today I am going to discuss a very important topic, and the name of the topic is Introduction to Linked List. So first I will discuss what is a linked list. So like arrays, the linked list is also a linear data structures, but unlike arrays, the elements of the linked list are not stored actually in contiguous memory locations. Rather, they are stored in different memory locations. Okay, so basically a linked list is a series of connected nodes. Okay, so now we are going to draw a simple figure of a linked list. So let's have a look on the board. Okay, so you can check. So these are the nodes of the linked list. So this is the first node of the linked list, this is the second node of the linked list, and this is the third node of the linked list. And each and every node has two different parts. Okay, so the first part is called the data part, and the second part is called the next part. Okay, and they are connected to each other. So suppose the address of the first node is 100, the address of the second node is 200, and the address of the third node is 300. Now I have assumed this address, but it may not be the address like that. So the address for each and every node is being allocated by the compiler during runtime. So whatever be the address compiler will allocate, we cannot predict in advance, or we can also not demand any address. So for the sake of understanding, we have selected the address for this node like 100, 200, 300 like that. So these are the data part. Okay, the first part. So suppose we want to store in the data part, actually you can store the data of the value actually of any data type. So you can store integer value, you can store float value, you can store character value, string value, whatever you want. So suppose you want to store integer value. So suppose the first node data part is 7, the second node data part is 4, and the third node data part is 9. We are storing some integer value. And in the next part, actually the next part is basically a pointer. So in the next part, it will contain the address of the very next node of the list. So 100 next node is 200. So 100 next part actually contain the second node address. Okay, so second node address is 200. So it is containing 200. That means 100 is connected with 200. That means 100 next node is 200. Now after 200, 300 is there. So 200 next part will contain the address of its next node, that is 300. So 200 next part is containing 300. So 200 is connected with 300, and you can see from the figure that after 300 no node is there. So 300 is the last node of the list, and since no node is there, that means its next part, that is 300 next part, will contain a null value. Okay, so if the next part of any node is containing a null value, that means after that node no node is there, that means this is the last node of the list. Okay, so here we have considered a single linked list having 3 nodes. Okay, so single linked list means each and every node will contain a single pointer, single address. Okay, so other types of linked list we will discuss very soon during the course of this explanation. Now this is the head. Actually this is a pointer. Now what head will contain? Head will contain the address of the first node of the linked list. Whatever be the size of the linked list, it may contain 2 node or 200 node. Irrespective of that, head will always contain the address of the first node. Okay, so what is the address of the first node here? It is 100. So head will contain 100. Okay, so now why this head is important? Because whenever you are working with a linked list, you cannot start from anywhere. You have to always start from the beginning of the node, beginning of the list actually. That means from the first node. So the keeping the address of the first node is very important. So if you can track the first node, and if you can reach to the first node, then from first node you can reach to the second node, and from second node you can go to the third node, and so on. Okay, so this is a very simple pictorial representation of a single linked list. Okay, now the next point we will discuss that why do we need a linked list. Okay, so before going to be familiar with the importance of linked list, first we have to know what was the drawback of an array. Okay, so first we will discuss the limitations of an array. Okay, now whenever you are going to work with an array, whatever be the dimension, it may be the one dimensional array or two dimensional array, before working with the array, you have to first declare the size of the array, and depending on the size, the compiler will allocate memory for that array. Now once you declare the size, you cannot increase or decrease the size later on during the execution of the program. That means you cannot update the size. Okay, why? Because the memory allocation in an array is static type. Okay, so during the execution of the program, if you have to work with some more elements, okay, so you cannot accommodate it due to the shortage of space. So basically the array size is fixed. Okay, now number 2 limitations of array is insertion and deletion operation is very expensive. Suppose there are 10 elements in the array you are working with, starting from index number 0 to 9, and if you want to insert a new element at index number 4. Okay, so what you have to do, first you have to vacate this place so that you can insert at that index 4. Okay, so to vacate this index number 4, what you have to do, you have to shift all the elements starting from index number 4 till end 1 bit right position, so that index number 4 can be vacant and you can insert the new element. Okay, so lots of shiftings are required. Similarly, if you want to delete an element from index number 4, so after deleting the elements from index number 4, what will happen? This space will become vacant. Now what you have to do, then after deleting element from index number 4, you have to shift all the elements starting from index number 5 till end to 1 bit left position. Okay, so again lots of shiftings are required. So insertion and deletion operation in an array is expensive. Okay, so to overcome this limitation of an array, we had to think of about a linked list. Okay, so now we will discuss what are the advantages of linked list. Okay, so the first advantage of a linked list is that it is dynamic in nature. That means whenever you need to create a new node to insert a new element, you can call the malloc function at the runtime of the program, and malloc function will create memory for that to insert the node or for that node. Okay, so you do not need to declare the size of the linked list before working with linked list. Okay, so it is dynamic in nature. Okay, number 2 point is the insertion and deletion operation is not a expensive job in case of linked list, because since here the elements are not stored or the nodes are not stored in contiguous memory location, so you do not need to shift any nodes. Okay, so suppose here from this linked list I want to delete second node. So what you have to do, you have to just made a connection between 100 and 300, that means between first and third node. Okay, so after first node, third node will come, so 100 next part will contain the address of the third node, that is 300. So here in place of 200 we will store 300, that means 100 next node will be 300, and then we will delete this node. So no shifting is required. Okay, similarly if you want to insert an element at between position 2 and 3, so what we will do, we will create the node here, then we will make a connection between second node and new node, and between new node and the third node. Okay, so we do not need to shift any node. So it is very easy to insert or delete a node in a linked list. Now we will discuss the different types of linked list. So point number 3 is types of linked list. Okay, so basically there are 3 types of linked list are there with which we have to work. Okay, so the number 1 is singly linked list. So first we will draw the figure. Actually the figure we have already drawn. So this is an example of a singly linked list. Now in a singly linked list, why the name is singly? Because each and every node will contain a single pointer. You check, this is the data part and this is the pointer part. So each and every node is containing a single pointer, that means single address, and that is the address of the next node. Okay, so this is the 100 first node, 100 next part is containing the second node address, that is 200. 200 next part, this is the next part, is containing the address of the third node, and third node next part is containing null, that means after third node no node is there, that's why it is null. So this is the last node of the list. So how can we recognize a node whether it is a last node or not? So you have to just check the next part of the node. If it is null, that means it is the last node of the list. And as I have told you that the first node address, here it is 100, will be kept in the pointer head. So head is a pointer to this first node. Okay, so this is the representation of a single linked list. Now the second type of linked list is doubly linked list. Okay, now what is doubly linked list? That means each and every node will contain double pointer, double address. Okay, so let's have a look of this diagram. Okay, so you can check each and every node has three parts. So this is the first node, this is the second node, and this is the third node. Okay, so this is the data part. So suppose we are storing the data 12, then 9, and then 5. So these are the data parts, and suppose these are the address 100, 200, and 300. Okay, so this is the first node. Okay, so first node next part will contain the address of the next node, that is 200. So this is the pointer which is pointing to the next node. That means the doubly linked list node next part will contain the address of the next node. Okay, as we have seen in case of single linked list. So 200 next node is 300, so 200 next part is containing 300, and 300 is the last node, so its next part will contain null. Now what is this? This is the extra part you can see that was not there in single linked list, but it is present in doubly linked list. So this is the previous part. So previous part is also a pointer, and which will contain the address of the previous node. So you check that 100 is the first node, so it is the first node, so no previous node is there before 100. So the 100 previous node address is null, that means it is the first node. Okay, that's why no previous node is there before that node, so that means its previous part is containing null. Now 200 previous node is 100, so its previous part will contain 100, and 300 previous node is 200. Okay, so 300 previous part will contain 200. So here this is the data part, this is the next part, that means it is containing the address of the next node, and this is the previous part. So in short we can write prev. Okay, so three parts are there in each and every node of a doubly linked list. So why is it called doubly? Because each and every node is containing double pointer, the particular node containing its previous node address as well as its next node address. So that's why it is containing, it is called double pointer. And look at the list, that as usual the last node next part is containing null. Similarly, the first node previous part is also containing null, since its previous node address is null. Okay, previous node is not there actually. And as usual the head will also be there for doubly linked list. So head will contain the address of the first node, and 100 is there. Again I am telling, this is not the address, we can assume or we can predict. It is the sole discretion of the compiler that whatever address will be allocated we have to consider. Okay, we hardly bother about the address. Okay, so this is the example of a, that means this node is connected in both way, that in this way. Okay, so in single linked list you can have only a forward direction move, that means you can proceed from 100 to 200, 200 to 300, and 300 to the next node. But from 300 you cannot proceed to 200, because in node number 300 the 200 information is not there, and in 200 its previous node, that is 100, information is not there. But in case of doubly linked list you can check each and every node is containing the address of both its previous node and next node. So you can proceed in both the direction. That means if you are in 100 you can go to the 200 and its previous node. Similarly, if you are at 200 you can go to the 100 as well as to the 300. So both way movement is possible in case of doubly linked list, but only forward direction movement is possible in case of single linked list. Okay, the third one is the circular linked list. Okay, now from the name you can understand that circular linked list means the nodes of the linked list will form a circle. Okay, that means after the last node, okay, so again the first node will come. Okay, so basically there will be no first node or last node. Okay, so it will form a circle. So let's have the figure to understand the circular linked list. Okay, so suppose we are considering a singly circular linked list. So each and every node is having two parts. So suppose these are the elements we have stored: 11, then 6, and then 15 in the data part, and 100 next part is 200, 200 next node is 300, so it will contain 300, and 300 next node. In case of singly linked list, we have stored null because that was the last node. But in case of circular linked list, it will form a circle so that the last node next part will contain the address of the first node. Okay, so what is the address of the first node? That is 100. So last node, that is 300, next part will contain 100. That means after this 300, again 200 will come. So it will be connected like that. So you can check 100 next part is 200, 200 next part is 300, and 300 next part is the address of the first node, that is 100. So it is forming a circle. Okay, and although there is no such first node or last node in case of circular linked list, but we will keep the address of the first node in a head pointer, and this is 100. So from where you have to start, otherwise we cannot track the linked list. Similarly, we can have a circular doubly linked list in the same way that we have done in case of circular singly linked list. Okay, so these are the types of linked list. Okay, now we will discuss that what are the different operations that we can perform on a linked list. So the point number 4 is operations in a linked list. So actually we can perform various operations. For example, insertion. So what is insertion operation? Insertion operation means we want to insert a new node in the existing list or even in an empty list. So the insertion operation can take place in the beginning of the list, or it can take place at the end of the list. Okay, so that is, if you are inserting a new node at the end of the existing list, that is, it is called append. And even after, you can insert a node at any position in the list. That means after a certain node position you can insert. Suppose you want to insert a node after second position, so a new node will be created, and we have made a connection between these two, second node and the new node and third node. So we can insert a node at any particular position in a linked list. The next operation that we can perform is deletion. Now what is deletion operation? So like insertion, we can delete any node from the linked list. Okay, so deletion operation can take place from the beginning, that means first node can be deleted. It can take place from the end, that means last node can also be deleted, or at any particular node. That means suppose you want to delete the node present at position 5, so you can delete. So what you have to do after deleting the nodes present at position 5, before deleting, what you have to do, you have to set up a connection between node number 4 and node number 6. So after setting up this connection between 4 and 6, then we can delete node number 5. So that's all. Okay, so these are the deletion operation we can perform. The next operation is searching. So from the name you can understand that searching operation means we can search whether a particular element is present in the linked list or not. So which part of we have to check? Only the data part, because the data actually present in the data part of the list. So we will check the data part. Now I am telling you that whenever or whatever be the operations you are going to perform in a linked list, be it a single linked list or doubly linked list or circular linked list, you have to always start from the beginning, because you cannot jump to any particular node. Okay, so you have to always start from the beginning. So we have to traverse each and every node, that means from starting node to last node, and you have to check the data part of each and every node. So if it is matching with the key values that you want to search, then our searching operation will become successful. Otherwise you will print that data value or the key value is not present in the list. Okay, so this is the searching operation. Then next operation is sorting operation. So sorting means what? You know that sorting means arranging the data in some specific order. You can sort the data in ascending order or descending order, in both the ways. That means only the data part will be sorted. That means if we sort this linked list in ascending order means the lowest value will come to the first node data part and the highest value will go to the last node data part. So after sorting, the data file will be arranged like 4, 7 and 9 if you want to sort in ascending order. Similarly, if you want to sort the data part in descending order, descending means the highest value 9 will come to the first node, followed by the second highest 7 and at last the 4. So this way we can sort this by using any sorting algorithm, selection sort, bubble sort, select, merge sort, quick sort, whatever sorting algorithm you want to follow, you can follow it, and this is the sorting operation which we can perform also in case of linked list. Next is we can count that how many nodes are there in the linked list. So if there are, for that linked list, if we implement the function count, then it will give us the output 3 because there are 3 nodes. So this is the count operation. Next, display operation. So what is display operation? Display operation means we can display or we can print the data part of each and every node. So if we work with the single linked list, then only the forward direction move is possible. So first the first node data part 7, then 4, and then 9 will be printed. Okay, so these are called display operation. Now you can also print the data part along with the address part, but we hardly bother about the address part. So if you want to print it, you can print it. The next one is the reversing the list. Reversing the list. Reversing the list means what? That means we want to reverse the entire list. That means your first node will become the last node and current last node will become the first node. Okay, and in between all the nodes between first and last will be changed accordingly. That means we have to change the link of each and every node. Okay, so this is called the reversing of the list. Entire list will be reversed. Next operation is reverse printing. So what is reverse printing? Reverse printing means we are not reversing the list. The list will remain intact as it is, but we will only print the data part in reverse order. So for that case, we will first, this single linked list will print the data part of the last node, that is 9, followed by the data part of the second node 4, and then the first node data part, that is 7. So the data part will be printed in reverse order. That means output will be 9, 4 and 7. Okay, so these are the various operations: insertion, deletion, searching, sorting, count, display, reversing the list, reverse print. We can perform in any kind of linked list, and we are going to define different functions for all these operations later on. Okay, now we will discuss the next point, which is representation of a linked list. Now representation of a linked list means what? That means how to represent the nodes of a linked list. Okay, it can be the singly linked list node, it can be the doubly linked list node. So for the time being, we are going to represent the nodes of a singly linked list. Okay, if we can represent the node, then we can make a connection between this node and the linked list will be formed. Okay, so you can check that each and every node, as I have told you, have two parts. So data part and the next part. So we can think of about the nodes of a linked list as a structure. Okay, so and in C language, if we want to declare a structure, you know that the keyword struct we have to use. So we are declaring the structure using the keyword struct, and the name of the structure is node. Okay, if you have any confusion then how to declare the structure, or if you want to learn, then you can go to the previous video where I have explained each and everything about a structure. Okay, so two members will be there. First is a data member. So here I have mentioned the data type as integer, so it will be in data. Now if you want to store character value, you can and declare this data part as cat data, or if you want to store a float value, then you can mention it as float data, like that. So it is up to you. And the next part, this is the next part, is a pointer. Okay, so it is a pointer to a node of the same structure. So it is pointing to another node, and this node is what? The structure that we are defining. So it is a pointer of struct node type. Okay, look at the declaration here. Next is the pointer. So this symbol, asterisk symbol, we are using to denote that next is a pointer. And what is the type of the pointer? Struct node type. Struct node type, that means this pointer can point to a node of this type of structure. Okay, so since this member this is a member of a structure which is referring to the same structure, so that's why sometimes this type of structure is also called as self-referential structure. Okay, it is referring to the same type of structure. So this is the declaration of the nodes of each and of a single linked list. Similarly, if we want to declare the nodes of a doubly linked list, so previous part you have to also declare. So that time you have to declare it like the struct node star previous also. Okay, so 3 parts will be there. Okay, and last point that we are going to discuss for today, that what are the disadvantages of a linked list. Okay, so already we have discussed so many advantages of a linked list. Okay, but there are certain disadvantages are also there for linked list. The number one disadvantage is that you can check to represent each and every element there is a pointer. Okay, so each and every node we are assigning a pointer. To assign this pointer, the extra memory is required. So if there are 100 number of nodes, so for each and every node there will be a location, there will be a space for pointer. So it will take huge amounts of space. Number 2 is that whenever you are dealing with so many pointers, it will be difficult for you to manage it. And another disadvantage is that you cannot start from anywhere whenever you are working with a linked list, as I have told you, because you have to always start from the beginning. So random access is not possible like arrays. Okay, using array index you can go to any element at any point of time, but if you are working with a linked list, you have to always start from the beginning. That means from the first node address. Okay, so sequential access is possible, random access is not possible. That's why we are unable to perform the binary search operation in case of linked list. So these are some disadvantage of a linked list. Okay, so students, I hope that you have understood the concept of the linked list. Okay, so thanks for watching. Please take care. Have a nice day.